organizations can collect data from various sources. But there's a bigger challenge when they have multiple offices and multiple distributors and big chain, and all the data cannot always be brought in centrally. Carries risk. How to train their softwares to work on the data collected in different locations. Welcome to my YouTube channel where you regularly find new content on data privacy. And we are going to talk about federated learning and see how we can solve this problem of data collection at multiple locations. So, what is the problem? The problem is that, of course, one is that you have multiple sources. So, it could be web, it could be an application, it could be a manual form collection where someone sits in the office and feeds that data into the system. Second, multiple geographies, multiple regulations. You could have branches across different countries. Even if they are within the countries, there are multiple locations from where you are going to collect the information. And bringing all the information centrally so that you can train your AI model, you train your machine learning models, can become very, very difficult. It can expose your sensitive personal information. Right? The information has to travel centrally. And if it is global, that is across the border, then you need to follow the cross-border norms as well, right? CBDT, cross-border data transfers. So, what is the solution? Sort of a federated learning where what we would do is that instead of bringing the data to the model centrally, we take the model to the data onto different geographies and locations. Right? So the model is shipped or downloaded at various geographies and it works on the data and sends only the analysis reports and not the actual data. That means the personal information collected at each branch, at each geography is not moved back. What is moved back is the inference, the result of collecting and the result of processing through the given MI model or given AI model. Devices are trained locally and central models are updated at an aggregator level or at the central level of the organization. Cross-border data transfer may still come into picture, but then you still have the situation where you are bringing not the personal data but the metadata and the analytics out of the personal data that you have originally collected. Benefits: personal data not coming into the central. It stays on the local device, it stays in the local location. So cross-border data transfer avoided, bandwidth data transfer avoided, the security, the chances of the data getting lost anywhere or breached at any end is avoided. Data stays local, stays protected within the regulatory compliance from where it has been actually collected. A real world use case, a couple of them. A mobile app. Keyboards are predicted, but every prediction does not go to central repository. Only the summary goes to the central repository. Apple uses it quite well. Healthcare. There are multiple offices, multiple hospitals. In fact, these days you have hospital chains, right? You have multiple hospitals bought by a single larger umbrella hospital. So you have multiple chains under one umbrella. If all of them keep sending personal data at a central location online, it can become difficult. So what do they do? They train or they run their models locally and send the final report and not the personal information of the patient. Same works with financial organizations. Fraud detection systems. No customer information is exposed to the central environment. What are the limitations and risks if you are using this model? It requires secure aggregation. You need to be very, very careful. It could be that the geographical requirement or the regulatory requirement of your branches could be different. So your models have to be prepared accordingly. You should still use privacy enhancement technologies like encryption. It needs a very, very carefully done architecture of it, and accidental data leakage is also possible. That's something which anyone is very standard. Accidental data leakage can happen from anywhere, and it's possible over here as well. So let's get started. What should startups do? They should start small, experiment on local models, and then experiment on hybrid models as well. And sooner or later, you realize or get tuned to the local models. You should adjust yourself to be on local models. Maybe do some differential privacy algorithms. What does that mean? You hide the personal information and you work on the remaining data, right? so system does not know to whom the information belongs to. Secure aggregation, stronger guarantees, and think in phases. Create a prototype, do some pilot, and then scale it up slowly. Don't just bring a large scale to work on. Start simple, scale responsibly, grow responsibly, take care of the privacy of the data that you have collected because your users trust your business. Key takeaways: it's a powerful privacy preserving approach. Data, personal data, does not move across the bandwidth. It protects users' data and protects you from risk of breach. It secures your compliance and users' compliance, and ideally not a standalone, at least encryption, if nothing else. That in any case you should do with any critical data, nothing specific to federated learning only. So that's about federated learning and managing privacy with federated learning. I hope you like the content of the video. Please press the bell and the like icon, subscribe to my YouTube channel, and share your feedback in the comment section. Thank you.